Students, very good morning. Today we are going to see 10th standard mathematics exercise 1.2 relation. Define relation. Let A and B be any two non-empty sets. A relation R from A to B is a subset of A cross B. A relation R from A to B is a subset of A cross B, satisfying some specific conditions. If X belongs to A is related to Y through R, then we write it as X related to Y. X related to Y if and only if X comma Y belongs to R, capital R. Relation capital R is a subset of A cross B. We know that how to find A cross B. The set of ordered pairs is called A cross B. All the elements from the set A and B. The first coordinate from the set A, the second coordinate of ordered pair belongs to set B is A cross B. A relation R from A to B is a subset of A cross B. Relation means subset of A cross B. That's all. The domain of the relation capital R is equal to X belongs to A such that X is related to Y for some Y belongs to B. The codomain of the relation capital R is B. The domain of the relation is X belongs to A. So always the set A is domain. The set B is called codomain. The element from the set A is related to set B. So X comma Y. Now the set of all images is called range. The range of the relation capital R is equal to Y belongs to B, such that X is related to Y for some X belongs to capital A. Here X belongs to capital A. The set of all elements in the set A is called domain. The domain of the relation is the set A. The codomain of the relation is set B. The range of the relation is Y belongs to B such that for every element X belongs to related to Y, for some X belongs to A. So domain means the set A, codomain means the set B, range means the set of all images. Note that the domain capital R, the domain of R is a subset of A. Codomain of R is equal to B. The range of R is subset of B. So the relation is a subset of A and subset of B. The codomain of R is equal to B. Okay. Now let us see the example 1.4. Let A is equal to 3, 4, 7, 8, B is equal to 1, 7, 10. Which of the following sets are relation from A to B? Here the relation R1 is equal to 3, 7, 4, 7, 7, 10, 8, 1. Now which of the following relation? You check whether R1 is a relation or not. Relation means what? The definition of relation is the relation R is a subset of A cross B. If it is subset of A cross B, then we can say that it is called a relation. Now R1 is equal to 3, 7, 4, 7, 7, 10, 8, 1. Check whether R1 is a subset of A cross B. Here A cross B is equal to 3, 4, 7, 8 cross 1, 7, 10. 3, 1, 3, 7, 3, 10. 4, 1, 4, 7, 4, 10. 7, 1, 7, 7, 7, 10. 8, 1, 8, 7, 8, 10. These are all the subsets of A cross B, elements of A cross B. Okay, now check R1 is a subset of A cross B. Subset means what? Every element of R1 is an element of A cross B, then we can say that R1 is a subset. Here every element of R1, 3, 7, yes it is there 3, 7. 4, 7 is an element of R1 and also element of A cross B. 7, 10 is an element of R1, is also, see here 10, 7, sorry 7, 10, yes here 7, 10. 8, 1, yes here 8, 1. So every element of R1 is an element of A cross B. Therefore A cross B, R1 is a subset of A cross B. Thus R1 is relation from A to B. Now second one, 3, 1, 4, 2. Check the elements of R2 is an element of A cross B. 3, 1 is in A cross B. But 4, 12 is not in A cross B. Therefore R2 is not a subset of A cross B. Therefore R2 is not a relation from A to B. In R3, 3, 7 is there. 4, 10 in A cross B. 7, 7 is in A cross B. 7, 8 is not in A cross B. 8, 11 is not in A cross B. 8, 7 is in A cross B. 8, 10 is also in A cross B. So 7, 8 does not belongs to A cross B. Therefore R3 is not a subset of A cross B. So R3 is not a relation from A to B. So hereafter, if R1 or R the relation is a subset of A cross B, then we can say that R1 is relation. Next, exercise 1.2. Let A is equal to 1, 2, 3, 7, B is equal to 3, 0, minus 1, 7. Which of the following are relations from A to B? A cross B is equal to 1, 3, 1, 0, 1, minus 1, 1, 7. 2, 3, 2, 0, 2, minus 1, 2, 7. 3, 3, 3, 0, 3, minus 1, 3, 7. 7, 3, 7, 0, 7, minus 1, 7, 7. Okay. Now check R1 is a relation or not. R1 is equal to 2, 1, 7, 1. Now check the elements 2, 1 and 7, 1 in A cross B. Yes, 2, 1 it is not there. 7, 1 is not there. Therefore R1 2, 1, 7, 1 belongs to R, but it is not in A cross B. Therefore R1 is not a relation from A cross B. R1 is not a relation from A to B. Okay, next R2 is equal to minus 1, 1. R2 is equal to minus 1, 1. Yes, minus 1, 1 is in R2 but not in A cross B. Therefore R2 is not a relation from A to B. R3 is equal to 2, minus 1, 7, 7, 1, 3. 2, 1 is in R3 but not in 2, 1, 2, minus 1, yes, 2, minus 1 is there. 7, 7, yes, 7, 7 is there in A cross B. 1, 3 is an element of R3, yes, 1, 3 is an element of R3. So every element in R3 is an element of A cross B. Therefore R3 is a relation from A to B. Next, fourth one, R4 is equal to 7 minus 1, 0, 3, 3, 3, 0, 7. Now 0, 3, 0, 7 belongs to R4 but not in A cross B. Therefore R4 is not a relation from A to B. So every element of relation R, every element of R is in A cross B, then we can say that R is a relation. Second sum. Let A is equal to 1, 2, 3, 4, 5, etc., 45, and R be the relation defined as is squares of on A. Write R as a subset of A cross B. Also find the domain and range of R. Okay. Here the set A is given. A is equal to 1, 2, 3, 4, etc., 45. Also given that the relation is square of. So R is equal to 1. The square of 1 is 1, square of 2 is 4, square of 3 is 9, square of 4 is 16, square of 5 is 25, square of 6 is 36. Now domain is equal to the first element of, already I told you that the domain means the set A is called domain. Here the first element of the ordered pair is called domain. 1, 2, 3, 4, 5, 6 is called domain. The second element of the ordered pair is called range. 1, 4, 9, 16, 25 and 36 is called range. Next, third sum. A relation R is given by the set A, x, y such that y is equal to x plus 3, x belongs to 0, 1, 2, 3, 4, 5. Determine its domain and range. First you have to find the set of ordered pairs of x, y according to the condition y is equal to x plus 3. Here x is elements of 0, 1, 2, 3, 4, 5. Now x takes value 0. Suppose x is equal to 0, then y is equal to 3. X is equal to 1, y is equal to 1 plus 3 is 4. X is equal to 2, y is equal to 2 plus 3 is 5. X is equal to 3, 3 plus 3 is 6. X is equal to 4, 4 plus 3 is 7. X is equal to 5, 5 plus 3 is 8. So the relation R is equal to the set of ordered pairs 0, 3, 1, 4, 2, 5, 3, 6, 4, 7, 5, 8. The set of ordered pair is equal to R. The domain of R is nothing but the first element, first coordinates of R 0, 1, 2, 3, 4, 5. The range of R is equal to 3, 4, 5, 6, 7, 8. Okay. The domain and range is over. Next, fourth sum. Represent each of the given relation, an arrow diagram, a graph, and set in roster form wherever possible. X, y such that x is equal to 2y. X belongs to 2, 3, 4, 5. Y belongs to 1, 2, 3, 4. Now, x takes value 2, 3, 4, 5. Y takes value 1, 2, 3, 4. Now, x is equal to 2y. Then y is equal to x by 2. Now substitute x is equal to 2, then y is equal to 1. X is equal to 3, y is equal to 3 by 2. X is equal to 4, y is equal to 4 by 2 is equal to 2. X is equal to 5, y is equal to 5 by 2. So arrow diagram, elements of x 2, 3, 4, 5, elements of y 1, 2, 3, 4. But here only two elements which has image, that x is equal to 2 and x is equal to 4. X is equal to 2, then y goes to 1. 2 goes to 1. X is equal to 4, then y is equal to 2. So 4 goes to 2. So arrow diagram is over. Next graph. X takes value 2, 3, 4 in x-axis. Y takes value 1, 2, 3, 4 right in y-axis. The graph is 2, 1, 4, 2. Yes, 2, 1, 4, 2. Graph is also over. Roster form x, y which satisfies the condition x is equal to 2y. Only two value which satisfies the condition x is equal to 2y. X is equal to 2, y is equal to 1. So 2, 1. X is equal to 4, y is equal to 2, 4, 2. So roster form is over. Second one, x, y, second sum, such that y is equal to x plus 3, x, y are natural number less than 10. Here the condition is given y is equal to x plus 3. X and y are natural numbers less than 10. So x takes value from 1 to 9. Y takes value from 1 to 9. When x is equal to 1, y is equal to 4. X is equal to 2, y is equal to 5. X is equal to 3, y is equal to 3 plus 3, 6. X is equal to 4 means 4 plus 3 is 7. When x is equal to 5, then y is equal to 5 plus 3, 8. For x is equal to 6, there is no image y value. So only up to x is equal to 5, we will have the y value, y is equal to 8 up to. So arrow diagram, 1 goes to 4. Here write all the values of x from 1 to 9. Y value, y is natural number less than 10, 1 to 9. Here 1 goes to 4, 2 goes to 5, 3 goes to 6, 4 goes to 7, 5 goes to 8. So arrow diagram is over. Next graph. Similarly, 1, 4, 2, 5, 3, 6, 4, 7, 5, 8, 6, 9. Next roster form. All the elements of x, y in the form of x, y. 1, 4, 2, 5, 3, 6, 4, 7, 5, 8, 6, 9. Okay, my dear students, today's session is over. We will see tomorrow. Please. Okay, thank you very much.